So here's the class opener explained. Let's take a look at number 1. Again, the thought process is, where's the x at? It's on the left side of the equal sign. Is it by itself? No, there's this minus 14 right there. So we need to get rid of that minus 14 by doing the opposite, which is plus 14. What you do to one side, you do to the other side to maintain the balance. So what do we have left? We have the positive x that comes down, the equal sign that comes down, and 14 take away 3, or negative 3 plus 14. It's like if you owe $3 and you have 14, of course you could pay them off. You will still have 11 left over. That's your final answer right there. And of course, you could always double check your answer. Take that 11, plug it back in. Negative 14 plus 11, you owe $14, you have 11, you're still going to have $3. And that is what we call double checking, right? So we know that 11 is the correct answer. Let's move on. On number 2, this is slightly different because the x is clearly on the right side of the equal sign. Here's x. It's not by itself. There's an 11 right there. But notice that this does not say x plus 11 or 11 plus x. It's really saying 11 times x. So you need to do the opposite of multiplying, which is dividing. So we put the fraction bar for division, and you divide by that same exact value, 11. And of course, on any equation, what you do to one side, you must do to the other. So the 11s cancel out. The equal sign comes down, the x comes down, and over here, negative 33 divided by 11, that's going to be a negative 3. So x equals negative 3 is your final answer. Number 3, we have 2/3 x equals negative 4. We need to get the x by itself. Of course, we don't want this fraction. We could get rid of the whole fraction at once by multiplying by the reciprocal, but I like to just get rid of the fraction itself. In other words, it would be nice if it were just 2x, right? It'd be nice if it were just 2x like that without the divided by 3. So if I want to get rid of this divided by 3, all I have to do is multiply both sides by the denominator 3. Now if there were more terms, I would have to multiply everything by the denominator 3, but there's only 2 terms here, so I want to multiply by 3. And notice that I put the multiplication of 3 up on top in the numerator position. And what I do to one side, I do to the other side. So the 3 over 3 really do cancel out. The 2x comes down, equals negative 12, because negative 4 times 3 is negative 12. So for my final step, I need to get rid of this multiplication of 2 that's in front of the x. So how do I get rid of the multiplication of 2? I do the opposite, which is dividing by 2. What I do to one side, I do to the other side. Again, they cancel. X, the equals comes down. Negative 6 is your final answer. Let's move on to number 4. On this one, we have a fraction equals 2, and of course x is clearly on the left side of this equal sign. It's definitely not by itself. There's a lot of things all around the x, so let's start getting rid of things. Let's first get rid of this divided by 5 by doing the opposite of dividing by 5, which is multiplying by 5. Again, the 5 is on top, the 5 on the bottom cancel out, so let's write down what's left. 3x plus 7. You know what? I forgot to multiply the other side by 5, right? Whatever you do to one side, we multiplied by 5, it canceled out. You must do to the other side. So let's multiply by 5 on the other side as well. So on the other side, we have 10, because 2 times 5 is 10. So what do we have left on our new equation? We have the 3x plus 7 that came down, and 2 times 5, which is 10. So now we've gotten rid of that fraction. Let's continue to get rid of everything else to get x by itself. So we have a plus 7 here. Let's get rid of that plus 7. You always get rid of that number that's by itself first. And what you do to one side, you do to the other. So the 7 and the negative 7 cancel out. Let's rewrite what we have left. We have a 3x left over, the equal sign, and 10 take away 7 is 3. So for my final step, I'm going to get rid of that 3 in front of the x by doing the opposite. There originally was multiplication between the 2, so I'm going to divide by that 3, divide by 3, that cancels. And over here it cancels, but what does it really equal? It equals 1. 3 divided by 3 equals 1, so x equals 1 is my final answer for number 4. And of course, if you wanted to check it, you could always take that 1 and plug it back in here and say 3 times 1 is 3, 3 plus 7 is 10, 10 divided by 5 is 2, and you've double checked it, you know you have the right answer. Let's move on to number 5 over here. It gets a little more fun. Now some people see this fraction and freak out and say, I need to get rid of this fraction. I'm going to multiply by 5, multiply by 5, multiply by 5, multiply everything by 5. But think about that. If you multiply 32 by 5, you're going to get a huge number. If you multiply 17 by 5, you're going to get a huge number. So why not hold off on getting rid of the fraction? After all, you could get rid of the minus 32 by simply doing the opposite, right? Or you could always think about what I always say. X is the movie star. This is the movie star's buddy. This guy's the loner, the bum at the corner. Let's get rid of this guy first. So let's go plus 32, which do to one side, do to the other, plus 32. You're going to have negative 3 over 5 with an x equals negative 17 plus 32. If you owe $17 and you have 32, you're going to have $15 left over. So I still need to get rid of this fraction, which is really a division problem. That's 3 divided by 5 with a negative in front. Let me get rid of this divided by 5 by doing the opposite of dividing by 5, which would be multiplying by 5. And what you do to one side, you do to the other side to maintain the balance. So of course the 5 and the 5 cancel out. Let me bring down what I have left over. I have a negative, a 3, an x, and an equal sign. And 15 times 5, that's 10 times 5, 50, plus 5 times 5, 25. 50 plus 25 is 75. So for my final step right here, I'm going to divide by negative 3 to get rid of that multiplication of negative 3 in front of the x. And what I do to one side, I do to the other side, divide by negative 3. So the x's, the 3's cancel, x comes down, x equals negative 25. So we're done with number 5. Let me just take a moment here. Let's look at all these equations we've solved. Notice that none of them on the class opener so far have had variables on both sides. So you have on number 1, you had an x on the left side, but no x on the right. X is on the left side only, x is on the right side only, x is on the left side only, x is on the left side only of the equal sign. So none of them have had variables on both sides, which is the final section on Friday's test, which is 2.4. Now if we look at number 6, that's the very first one that has variables. You have an x here and an x over here. So you have x's on both sides of the equal sign. So this is the very first equation in this whole class opener that we're going to be solving that has variables on both sides from section 2.4. And keep in mind there's going to be 11 of these types of questions coming out on the test Friday. And those questions are selected from worksheet 2.4 WSP and worksheet 2.4 WSPM, which we received yesterday and we're receiving today. So anyway, let's solve, and the goal is to get x by itself on one side. We have x's on both sides, so let's get rid of one of the x's. You might say, I'm going to get rid of the 7x by doing a minus 7x and a minus 7x, but then you'd have a negative 3x over here. So maybe you don't want to do that. Maybe you want to get rid of the 4x and move it over there. So that'd be a good idea. Let's subtract 4x and subtract 4x. So your new equation will be negative 9 equals 3x plus 12. So once again, these guys canceled. The negative 9 came down, the equal sign came down. 7 take away 4 is 3. 12 comes down, the plus 12 comes down. So now we have an equation no longer with variables on both sides. Now it's just back to the variable on one side, which is clearly on the right side of this equal sign. So let's get this x by itself, right? What do we get rid of first, the 3 or the 12? Obviously the 12. So let's get rid of that 12 by doing the opposite of plus 12, which is a minus 12. What you do to one side, you do to the other side. So you owe $9 and you owe $12. Man, you owe a lot of money. How much do you owe altogether? You're gonna owe $21. Bring down the equal sign, bring down what's left over on the right side of the equal sign, which is the 3x. That comes down, the equal sign came down. So for my final step, I need to get rid of this 3 that you're multiplying with x. So I want to get rid of that multiplication of 3 by doing the opposite, dividing by 3. And of course, what I do to one side, I do to the other. The 3's cancel. So my final answer is, let me move this up, I have negative 7. Negative 7 equals x, and of course write it like this, x equals negative 7. There we go. Of course you could take that negative 7 and plug it in right here and right here and make sure that it gives you a true statement on both sides. So you're probably thinking that we're done, but the truth is, if we take this board and this board, as we are doing in class, and we open it up, we will see number 7, the final question of this class opener. Now this definitely is from section 2.4. It's a multi-step equation that requires simplification both on the left and right side. So let's do one side at a time. Let's look at the left side. Is there anything to do on the left side? Yes, there's distributive property. So let's take that 3, distribute it. 3 times 5j is 15j, and 3 times 2 is positive 6. So we've simplified the left side. There's nothing else to do. You can't add these guys because this is a j and this is a number, so you can't add letters with numbers. So let's now look at the right side and simplify the right side. I'm going to distribute this 2. 2 times 3j is 6j, and then 2 times negative 6 is negative 12. And of course I'm going to bring down the equal sign right between my two sides there, straight down. So now I have a simplified equation. The first equation was not simplified, now it's simplified. Now I need to get j by itself on one side. So I want to get rid of this 6j by doing the opposite of 6j, which is subtracting 6j, or negative 6j. That way it cancels out. And what I do to one side, I do to the other. Now you might be thinking, do I do the minus 6j right here? No, remember you can't do adding or subtracting with numbers and letters, so you're going to do the j's with the j's. So let's put that minus 6j over here, and 15 take away 6. If you have 15 j's and you owe somebody 6 j's, if you have $15 and you owe somebody $6, you're going to have $9 left over, but in this case 9 j's. So 9j, bring down the plus 6, bring down the equal sign, bring down the 12, but let's not forget that it's negative, right? That negative 12 comes down. So anyways, here's your new equation. And now let's get j by itself. Of course, you get rid of the 6 first by subtracting 6 to get rid of that plus 6. What you do to one side, you do to the other side. So right here on the right side, we have negative 12 minus 6. If you owe 12 and you owe 6, you're going to owe a lot. How much are you going to owe? You're going to owe 18. And of course, we're going to bring down the equal sign right there, bring down the 9j, and there's our new equation. We need one more step, then we will be done. Let's get rid of that multiplication of 9 by doing the opposite, dividing by 9. So we're going to divide by 9 and divide by 9. Final answer, j is actually negative 2. Negative 18 divided by positive 9 is negative 2. Once again, if you're taking a quiz and this question's on the quiz, actually test, and it probably is on the test this Friday because it's on the homework and it's on this video, then you could plug it back in. You could take that negative 2 if you have time, plug it in, and take that negative 2 right here and plug it in. And if it works, if you work it all out and it does give you something true, then it is your correct answer.